Okay, so when we differentiate from first principles, it's a formal way of basically doing what we could do with the power rule in a couple of seconds. I mean, the power rule, if I was to differentiate this, 5 minus 3x, I know that the answer is minus 3. It doesn't take any time at all. But we have to use the following headings to do the same thing. So just a formal proof. We'll set it up more in class in terms of where this proof comes from, but we basically just need to learn these headings here, and in particular the last one. The rest of the headings are just building slowly to get this last heading here. Okay, so let's see how we go ahead and do this. So we have a linear function. Now I'm going to make up a different one for the purpose of this so that you can go and have a go at this one here. But my one is going to be 7x minus 4. Now again, at the start I could use the power rule and see that the derivative of 7x minus 4 is 7. But I'm not allowed to do that if it says do it by first principles, which is the formal proof of it. So first step is you write down f of x. So we've done that. The second step is to replace any x's with x plus h's. So the f of x plus h is equal to 7 on x plus h minus 4. And that's all we do. Any x's that are in the question, we replace them with x plus h's. The next step is we're going to subtract one from the other. We're going to subtract the top line from the second line. So f of x plus h minus f of x is equal to the second line, 7 on x plus h minus 4, minus the top line, but just make sure you put it in a bracket so that you subtract it all. You then have a couple of lines of tidying up. So depending if it's a linear like this or a quadratic, there might be more or less tidying. But in this one, 7 by x is 7x, 7 by h is 7h, minus 4 minus 7x plus 4. And the number of terms in the original function, 2, is the number of terms that will cancel. 7x minus 4 plus 4. So we're left with 7h. That's that step. The next step says now divide every term in the question by h. So the f of x plus h minus f of x, which is what we've written down, we're going to divide any of those terms by h. So 7h divided by h is 7. And then that's that step done. And then the final step says that if there's any h's left, just make them 0. So the limit as h tends towards 0 of the line above, well, we can see in the line above there is no h's. We still just have the 7. If there was h's in it, which we'll see with a quadratic one in a second, we would turn them into zeros. So the answer to this question, differentiating 7x minus 4 from first principles, is 7. Now we had that done a couple of minutes ago using the power rule, and it was way shorter, but you won't get any marks for that if they say differentiate from first principles. They'll only ever ask us to do linear ones like this or quadratic ones, which we'll see in a second. Okay, let's do another linear one, similar to the one that's in the essential pack. We have, let's do f of x equals, just do 1 minus 2x. Now again, I can see that the derivative of that using the power rule is minus 2. Very easy, very quick, but you won't get any marks. You have to follow these steps here. So f of x equals 1 minus 2x. Well, f of x plus h, we take any x's and we replace them with x plus h. Then we take the second line and we subtract from that the first line. So the difference between these two. So it's 1 minus 2 on x plus h minus, in a bracket, 1 minus 2x. Underneath we tidy it up, so we have 1 minus 2x minus 2h minus 1 plus 2x. And as before, the number of terms in the function, the original function, that's how many terms cancelled. So minus 2x plus 1 minus 1. And we're left with minus 2h. The next step is to divide all of the terms remaining by h. So we're left with minus 2. And the last step is, if there's any h's left in the sum, which there isn't here, but if there was, they would turn into 0. And so we have minus 2. And again, we had that 2 minutes ago, and here we have it again from first principles. But that's the only way you'll get the marks if the question says differentiate with respect to x from first principles. Okay, let's have a look at a quadratic one. So you can do this linear one yourself. And then this is the quadratic one we have. Again, I'll make up a separate quadratic one. The steps are exactly the same, it's just we have more terms. So let's have something, you know, fairly straightforward. We'll do x squared as well, and we'll do plus 5x plus 7. So First thing I would do is, just so that I know what the answer is going to be, is I would just differentiate that. 2x plus 5. So I know that that's what the answer is going to be, but I'm not going to get any marks for that unless I do it from first principles, which is writing down all these headings. So I've written the function. I'm going to replace all the x's with an x plus h. That's what this second step says. This x here is x plus h squared now. The 5 by x is now 5 on x plus h, and then the 7 is still just 7. We're going to take the second line, and from that we're going to subtract the first line, and we get x squared, we get x plus h squared. So the second line, x plus h squared, plus 5 on x plus h, plus 7, and we're going to subtract x squared plus 5x plus 7. Now there's a couple of lines that tied in up here. So square in a bracket, we square the first, square the last, and twice the product. So that's what we get. Then we have 5x plus 5h plus 7 minus x squared minus 5x minus 7. There was 3 terms in the original function, so 3 terms will cancel, x squared and x squared, 5x and 5x plus 7 minus 7. I'm going to write down what's left, which is 2xh plus h squared plus 5h. Now, we're going to divide every term by h, so anything that has a h in it, we're going to divide by. So 2xh divided by h is 2x, h squared divided by h is left with h, and then 5h divided by h is 5. And then the last step is, if there's any h's remaining, then we make them 0. So there's a h here, and so that's a 0, and we're left with 2x plus 5, which is what we had again 2 minutes ago using the power rule, but we're not allowed to use the power rule when we do by first principles. Okay, so have a go at those two, and if people are interested, you know, there is more in this pack that get a little bit more difficult, but this is something we're definitely going to come back to. When we first did differentiation, we just wanted to know how to differentiate so we could get into questions about functions and graphs and rates of change and maxes of mins, and didn't want to get bogged too much down with the theory, but this is important to look at some class in the future. But you can see yourself that the steps to actually doing the question are easy. Something that's tricky to understand maybe, but easy to do.